All right, so this math lesson comes from chapter 4, lesson 1. We are doing multiplication patterns with decimals. So if I have this problem, which you see on the screen, it says 1 times 75 hundredths. I know 1 times any number is always going to be that number. So this is going to be 75 hundredths. Now I have 10 times 75 hundredths, 100 times 75 hundredths, and 1,000 times 75 hundredths. I'm seeing that my factors over here are powers of 10 and they're whole numbers. So if I see a 10, 100, or 1,000, I know I need to be moving my decimal point in this second number, or I guess if it was in the first number, to the right. I need to be moving my decimal point to the right. So let's see how we're going to do that. So if I have the number 10 and I'm multiplying it by the factor 75 hundredths, I can see how many times to move my decimal point based off of the zeros in this power of 10. So I see that I have 1 0 here. So that means I'm going to move my decimal point 1 time to the right. So my answer, my product, is 7 and 5 tenths. Now, if I go to the next problem, I have 100 times 75 hundredths. In my power of 10, 100, I see I have 2 zeros. So it's telling me that I need to move my decimal point to the right 2 times. So 1 time, 2 times. So when I figure out my answer, I see that my product is 75 and my decimal point's now after that 5. Now this last one here is 1,000 times 75 hundredths. I see in 1,000 it's a power of 10. So I'm going to be counting the zeros. Well, I have 3 zeros here. So that means I need to move this decimal point 3 times. So once, twice, 3 times. Well, in this space here, I'm actually going to fill in a 0 into this place because I'm adding another place value. So my answer is now 750, and my decimal point would be after that 0. So let's look at another one. If I have 1 times 17 and 4 hundredths, I know any number times 1 is always going to be itself. So it's going to be 17 and 4 hundredths. Now when I look at 10 times 17 and 4 hundredths, I see that this is a power of 10. It's a whole number. So I'm going to be moving my decimal point to the right on these problems. So I'm going to look for how many zeros. There's 1 0 here. So that means I'm going to move my decimal point 1 time to the right and make my number, my product, bigger. I want it to be a bigger number, a larger number. So this now becomes 170 and 4 tenths. So I look to the next one. I have 100 times 17 and 4 hundredths. I have 2 zeros, and I see that it's a whole number. So I'm moving to the right. I'm going to move my decimal point 1 time, and I'm going to move it a second time. So this answer now is 1,704, and my decimal point will be at the end. I'm not adding extra numbers. I'm not doubling up on extra numbers. I'm simply just moving the decimal point in these problems. So now my last one is 1,000 times 17 and 4 hundredths. Well, I see this is a whole number, so I'm moving to the right, and I'm going to count my zeros. 1, 2, 3. So I know I need to move my decimal point 3 times. Once, twice, 3 times. And in this place value that I've just added, I'm going to add a 0. You're only adding zeros to the end when we're multiplying by a whole number. So this now becomes 17,040. Let's look at if we're multiplying by decimals. So I have this problem here. I am multiplying my numbers by decimals now. So again, 1,353 times 1 is always going to be itself. 1,353. Now, I see that this is not a 10, it's not 100, and then they're not 1,000. These are decimals. So when I have decimals that I'm multiplying by, if I have 1/10, 100th, if I had 1,000th, I'm now moving my decimal point to the left because I want a smaller answer. So I don't see a decimal point, though, in this whole number. When you don't see a decimal point in the whole number, don't create a decimal point. It's actually just hanging out in the back. It's invisible. You can't see it. So my decimal point's at the end behind this last 3. So when I have a decimal here, like 1/10, I'm going to know how many times to move my decimal point to the left based off of the amount of numbers after the decimal. So in this case, in 1/10, I only have one number after the decimal point. So I'm going to move my decimal point one time. So my answer now becomes 135 and 3/10. So when I'm looking here at 100th times 1,353, I'm going to know how many times to move my decimal point to the left based off of the amount of numbers after the decimal point. I have one number, then I have a second number. So that means I need to move it 2 times to the left. Once and twice, puts it between this 3 and this 5. So now my product is 13 and 53 hundredths. Let's look at one more. I have 38 times 1. I know any number times 1 is always going to be itself. So I'm going to keep it at 38. Now I have my decimals, my 10th and my 100th on the right side. You're going to do the exact same thing. It's the exact same thing as the problem that we focused on prior to this one. So I see that I have 1/10, and then I see I have 38 as a whole number, but there's no decimal point here. So because there's no decimal point, your decimal is invisible, and it's hanging out after that number 8. So I'm going to count my place values after the decimal point. I have one number after the decimal point. So that means I need to move my decimal point 1 time to the left because I am multiplying by decimals. My 10th, my 100th, if I had 1,000th. So my answer becomes 3 and 8/10. I want my answer, my product, to get smaller each time. So if I look at 100th times 38, I'm going to count how many numbers I have after the decimal point. I have 2. So I'm going to move my decimal point once, and I'm going to move it twice. So my product is decimal point 38. Now, you might see some problems that have exponents instead of a whole number or a decimal. Those problems are really they're really saying whole numbers. They are really those power of 10s. That's what these are. So anytime you see a 10 with an exponent of 0, you need to know that that is saying the number 1. Anytime they see a 10 with an exponent of 1, you need to remember that that's saying the number 10. And anytime you see a 10 with an exponent of 2, that is saying the number 100. And anytime that you see a 10 with an exponent of 3, that is saying 1,000. These are things that you need to remember as you're going through your problems.